We're going to look at the preparation of an ether from an alcohol. This is not terribly difficult, but you do need to have two equivalents of your alcohol. And what happens here is you are going to use concentrated strong acid and heat. It's very important that it is concentrated. So these would be the conditions you were looking for. What is going to happen is with a strong acid, you are going to have a proton source available to you. And out of all of these atoms on the alcohol, only oxygen is electronegative, so oxygen is going to have to accept the proton from your acid. And it is very important that you use an oxyacid so that we don't do any SN2 substitution and create an alkyl halide. We don't want something like that to happen. So oxygen will pick up your proton, you'll give electrons back to this oxygen, and you create an alkyl oxonium ion. And the corresponding conjugate base has resonance stabilization of its negative charge, so it's not a very good nucleophile. But again, if you'd used an alkyl halide, the halogen could now come in and do an SN2 substitution. We don't want that to happen. We are not here trying to make alkyl halides. That's why you avoid those. You need to be using an oxyacid for this purpose. So if that is no longer a good nucleophile, you've got a couple of options. Elimination is a possibility. It really is. But if you have a lot of alcohol present, it can act as the nucleophile. And this works really well with primaries for this reason, because they prefer doing SN2 substitution. If, on the other hand, you were using a secondary or a tertiary alcohol, it's actually quite likely to do the elimination pathway. Those are preferred. So this tends to work best with primary alcohols. Now, at this point in time, oxygen will act as the electron pair donor to this carbon, and this pair of electrons will be given to the oxygen since oxygen is more electronegative. It's doing an SN2 substitution. It's just that the nucleophile is the neutral solvent. It's a better nucleophile than the hydrogen sulfate anion. And primary substrates, if you remember, prefer doing substitution almost all the time. The only time they ever do really E2 elimination is with a strong bulky base. They prefer doing an SN2 substitution. But again, if you were trying to use a secondary or a tertiary alcohol, elimination is probably very likely. So you want to be using primary alcohols for something like this. Now, when this proceeds, this is now where we're at. So you've still got a protonated oxygen. And at this point in time, you need to give the proton to someone. Another alcohol molecule is most likely to start the process again for another set of molecules. So we're not going to go through the process for another whole set of molecules, but one of those oxygens will pick up proton. This pair of electrons is given back. And at the end of all of this, we've been able to make diethyl ether. And we've also regenerated the acid catalyst, since it can't go anywhere, really. You also could have given that proton to the HSO4- if you'd wanted to. That would have been okay.